we're going to write the inverse of a function. And we're going to keep it linear functions here. So you may have something like f of x equals 2x minus 5. And there's different ways that you can go about this, but the way I'm going to show you is first change f of x to y. We're then going to switch x and y. And we're then going to solve for this y. Okay, so get y by itself. So I'm going to add 5. Okay, so it's just x minus 5 on the left, 2y on the right, divide by 2. The 2's cancel. We then put the inverse symbol. So the inverse symbol is f inverse of x, like this. Okay, and also did switch the sides there. Notice in the original problem, we were subtracting 5, and the inverse, we're adding it. In the original function, we're multiplying by 2, and the inverse, we're dividing it. You could write this as 1/2 x plus 5 halves if you wanted to. Another example, call this one g of x. So we have something like this. Again, change g of x to y, and by the way, it's called g. The function's name is g. That's no different than it being an f. Okay, so y equals x minus 3 over 6. We'll then switch the positions of x and y. To get y by itself this time, we want to first get rid of the 6. We'll multiply both sides by 6. 6x equals y minus 3, and finish by adding 3. Then we'll change it to g inverse of x. Again, the same symbol. This has a little -1. This is just notation. Okay, it has no computational significance. So it would be, those cancel, it would be 6x plus 3. All right. While I'm at it, I'm going to go ahead and show you the switch that you do from an exponential function or an exponent form to logarithmic form. Go ahead and add that in here. It may not be of interest according to what you're studying, but we'll go ahead and do that. So we have a simple exponent statement such as 3 squared equals 9. In logarithmic form, you would write log 3, and that is written as a subscript. So it's written both small and low. 9 is equal to 2. Okay. So 2 things you're looking for. You're changing the order, but you're also writing it in the correct script. The order, a lot of people, they'll just kind of do an arrow like that to let them know that the first thing you write is the first number you see, but the second thing you write is the last thing you see, and you come back to the middle term. But again, we want to make sure that this doesn't end up looking like 3 to the 9th power, because it's not. It's a little 3 and a normal 9. Okay, as another example, 5 to the 1/2 power is equal to the square root of 5. The exponent rule, you may or may not know there, but it just doesn't really matter about that. I want to say log. Again, use this little arrow trick if you want to. A little 5. And then if you follow the arrow, you'll next write square root of 5 is equal to 1/2. Okay. Now, if we want to go backwards, it says already in that form, log base 5 of 25 equals 2. Basically, you want to write this the same way as this. Okay, you're going backwards. So I want to put it in this form. So I'm going to say 5 squared. It's the same order. 5 squared is equal to 25. Notice I wrote it as a typical exponent. This 2 is now superscript. But log base 5 of 25 equals 2 and 5 squared equals 25 are actually very related. They're stating the same thing. That's us switching back and forth between exponent form and log form.